Dysfunctional breathing starves your cells of oxygen. To understand why this happens, we must understand hyperventilation. Hyperventilation is simply breathing more air than your body requires. If you have not had a hyperventilation attack yourself, you've probably at least seen one on TV or in the movies. Generally, hyperventilation is characterized by big breaths, in and out through the mouth, with the shoulders and chest rapidly rising and falling. If hyperventilation continues, it can lead to tingling and numbness in the extremities, muscle spasms, anxiety, lightheadedness, and if it continues long enough, it can even lead to a loss of consciousness. These symptoms are fascinating because all we're doing is breathing more air, right? You might even be wondering, doesn't breathing more air just increase oxygen levels in the body? The answer is no. In fact, it does the exact opposite. When we breathe more air, oxygen availability in the body drops. To understand why this happens, let's look at a brain scan image. This brain scan shows oxygen levels in the brain. On the left is the brain of a person who is breathing normally. And as you can see, oxygen levels in many areas are up over 90%. Well, this same person was asked to hyperventilate for just 1 minute. The brain scan on the right was the result. As you can see, oxygen levels drop by as much as 50%. So just by breathing more air for 1 minute, this person decreased brain oxygen levels by about 50%. To understand why this occurs, we need to understand the medical definition of hyperventilation, which is the excessive rate and depth of respiration leading to abnormal loss of carbon dioxide from the blood. Notice how there is no mention of oxygen. In fact, no definition of hyperventilation mentions oxygen, but they all mention the abnormal loss of carbon dioxide from the blood. So when we hyperventilate, what's really going on is that we actually exhale too much carbon dioxide. And this is a big deal because carbon dioxide plays a vital role in delivering oxygen to the cells of the body. Low levels of carbon dioxide in the blood impede oxygen delivery through two well-known physiological effects. The first effect is called hypocapnia-induced vasoconstriction. This means that carbon dioxide affects the dilation of our blood vessels. Below are cross-sections of our blood vessels. On the left is the blood vessel with normal carbon dioxide in the blood. The smooth muscle lining that surrounds the blood vessel is relaxed and allows for optimal blood flow. But when we hyperventilate and carbon dioxide levels drop in the blood, the smooth muscle lining will spasm, which constricts the blood vessel and reduces blood flow. This places extra burden on your heart, as your heart must work extra hard to pump blood throughout the body. The next effect makes matters even worse. It is called the Bohr effect. The Bohr effect was discovered in 1904 and teaches us that carbon dioxide signals the release of oxygen from the hemoglobin. Hemoglobin is the molecule inside the red blood cell that carries the oxygen throughout the body until it is signaled to release it. Well, carbon dioxide is the primary signal to release oxygen. So when we hyperventilate and carbon dioxide levels in the blood drop, the hemoglobin holds on to more of the oxygen, making less oxygen available to the cells of the body. So if we combine these two effects, when we hyperventilate, not only do we get reduced blood flow throughout the body due to vasoconstriction, but the blood that does arrive holds on to more of the oxygen due to the Bohr effect. This is what we call the state of loss, or limited oxygen supply. In the state of loss, our cells are literally starved of oxygen. And this is a big deal because all chronic pain, suffering, and diseases are caused by a lack of oxygen at the cell level. This quote is from the medical textbook of physiology. Most people have no problem getting enough oxygen into their blood. That is, unless they have COPD, congestive heart failure, or one of another few lung diseases. The main issue, what we're focused on, is getting the oxygen from the blood to the cells of the body. For this reason, it is so important to understand minute ventilation. Minute ventilation is a medical measurement of the volume of air a person breathes in 1 minute. It is generally measured in liters per minute. This is a chart of minute ventilation over the past several decades. The gray bar represents the normal range of 4 to 6 liters per minute. Back in the 1920s, 1930s, and 1940s, people naturally breathed in this range. But beginning in the 1950s, something started to change, and minute ventilation began to increase, to where now the average adult breathes 12 liters of air per minute. That's 2 to 3 times the normal range. This does not mean that people are constantly having hyperventilation attacks. This means that each hour of each day, people are breathing more air than they should be breathing. This is a chronic form of hyperventilation. This is what we call overbreathing. Overbreathing is a widespread form of dysfunctional breathing. It is estimated that over 90% of adults chronically overbreathe, most without even knowing it. This means that over 90% of people are perpetually in the state of loss or limited oxygen supply. So every minute of every day, over 90% of people are starving their cells of oxygen. It is so important to understand this breathing paradox, which is that as your breathing volume increases above the normal range, the amount of oxygen available to your cells decreases. Dr. Claude Loom wrote, "Symptoms of chronic hyperventilation may show up anywhere, in any organ, in any system, for we are dealing with a profound biochemical disturbance, which is as real as hypoglycemia and more far-reaching in its effects." You may be wondering what increases breathing volume, or why has minute ventilation increased so much over the past several decades? The answer is simple. The answer is modern stress. In the next video, we are going to talk about how modern stress hijacks your breathing volume.